everybody. Welcome back to another MyTutor online school tutorial. Today we're looking at completing the square for GCSE Maths. So this session is 1 hour long, so it'll finish at 3 p.m. This is me, Molly, who's running the session. Most of you probably know me by now. Just finishing my second year studying computer science and maths at Bath. And I've done a lot of lessons with MyTutor and a lot of these now. So hopefully that means I know what I'm doing. So a couple of things. First of all, I hope a lot of you filled out the survey at the end, the type form at the end of last time. I'm not sure if one will be coming again at the end today, but I'll let you know, so just look out for that. And please do make use throughout of the chat and Q&A functions. It's super useful just for me to know that you're all still with me, I'm going at the right pace, and just ask any questions, like if you want me to go back to an example or anything like that. So to start with, as per, we're going to do a beginning Kahoot. So we do one at the beginning and one at the end. And they're different Kahoots, but they're really, really similar style of questions. So the same number of questions, the same difficulty. And it's just to see where people are at the beginning, what needs the most focus, so that then we can progress so that I know how best to run the session. And then we'll see if we improve at the end. So see if I've done my job right. So I've popped the Kahoot code on the chat as well, just so that if you haven't got a chance to join by the time that I start, I keep it unlocked so that you can join throughout. So whilst everybody's joining, get everything ready. So a bit about today's topic, completing the square. So we've gone over factorising before, and I think briefly the quadratic formula. So completing the square is another way of working with and solving quadratic equations. But the other super useful thing is that we can also use it to tell us about minimum points on a curve. So we'll find out how to do that. If you already know, there are some questions in this Kahoot on that, but if not, you'll definitely know by the end. And we're going to take it right from the base level of what on earth it is, how to do it, right up to some really difficult, first of all, questions with some horrible fractions and taking factors out, and also some kind of longer word questions. We have to work out what to do, interpret the question, that kind of thing. So there are currently 25 people here, 13 in the Kahoot. So I'll just give it 1 more minute. I'll go to 5 past for people to join, and then I'll get going. I like that there's a 10p Asda bag as per, but now there's also 9p Tesco bag. I love these names. Is anybody who's here still waiting to join, or am I good to get going? Okay, I don't think no one's told me to wait. So feel free to just join using that link. Yeah, I'll be which supermarket bag will come up top? That's the real question. Okay, so there's only 5 questions, but they take a bit longer to work out on that. So first of all, just starting with an expansion. The reason being that we're going to actually use expansion in completing the square. So I want to make sure that everybody's comfortable with this and knows what they're doing with this. This one I'll skip before the end. Hopefully we don't need that long. Okay, unless anyone's joined, this is everyone. So I'll skip when it gets down to 55, just in case anyone else is waiting. Oh, there was someone else. Oh, there you go. That's everyone. I didn't even have to skip. Fantastic. Okay, cool. So the way that we do this one is we take everything in this bracket, multiply it by this one. So x squared, 6x, a 2x, and a 12. And I'll be going over that in more detail in the lesson. But yeah, that's really, really great. Okay, so now just kind of throwing you straight in with a completing the square. If you have no idea how to do it, don't worry, either take a guess or leave the question. You don't have to be able to know how to do it now. You know, this is the content of the lesson. Awesome. So a lot of people got that, which is really good. Don't worry if you didn't know how to do it or weren't sure, but well done to these people who got it here. Okay, just a little bit of terminology to help you out with this one. When we say vertex, it means a turning point. So in a square, it's this point at the bottom. It's called a vertex. So this is what I was saying. You can use the completed square form to read off what that is. You know, guess if you need to, or try to think about it. Probably don't have time. If not, don't worry. We'll learn how to do this. Okay, tricky one that. I can see why some people went here. Yeah, it's -3, -5. I won't explain now, but you'll see why in the lesson and you'll be able to go back to it and get it right. So now it's solving, and you'll need your calculators for this one because it says 3 significant figures. So yeah, obviously I can't stop you from using it from a different, using a different method, you know, quadratic formula, plug it into your calculator, but try to do it by completing the square. These quizzes are to help. Oh God, I sound such a stereotypical teacher, don't I? Like, these tests are to help you. It's true though. If you don't have a calculator for these, you can just pop in the chat your answer in third form and I can let you know whether or not you got it right. Let's see for this one. Okay, interesting. Another difficult one here. Oh, the people that got these super close. That could be definitely a rounding error. So I'll teach you how to avoid those in the lesson. Final question. So this is, again, we're thinking about, so this here, this -3, -2 is, that's the vertex. That's what that terminology means. So this is kind of the reverse of what we were doing before. I'm thinking, which one could it be? Excellent. So the majority, like that was the one with the highest number of people. Well done. And we'll see why during the lesson. So let's see who's on the podium for this initial one. Kessia, well done. 3 out of 5. That's really good for having not actually done the lesson yet. And you've got 4 out of 5. Oh, and someone got 100%. Smart dude. Smart dude's been at the top before. Classic. Well done. So that's fantastic. And we will be going over some even more difficult questions than that. So even if you found that fairly easy, even better. So 44% at the beginning. That's already fantastic. So you guys already have a lot of the skills needed. And then we'll just build on that today. So let's get going. So to start off with, why on earth would we complete the square? You know, why wouldn't we use another method? What's the point of the format that it's in? You know, why does it exist? So to think about this, we might have to do a couple of examples because that's how we kind of see best. Once you put it into practice, you can see why not. So Manav's come up with a really good solution there. When a quadratic cannot be factorized. Yeah, exactly. If we maybe don't have a calculator to hand or for some reason can't use a quadratic formula, then completing the square is the next best thing. If you can't factorize something, as we'll see in a moment, it's actually quite easy to solve using completing the square, as was one of those questions in the quiz. The other reason is that it tells us about these turning points, these vertices of a curve, and that's super useful. So, you know, when we have straight lines in the form y = mx plus c, we have it in that form so that we can read off the gradient. And we have quadratic curves in completed the square form so that we can read off the turning point, the minimum or the vertex. And you will see these and why they're actually useful throughout the lesson. Like, as I said, it's one of those things where you'll understand why you're doing it through just doing it. So let's jump in with an example. You'll be pleased to know I'm on Maths Made Easy for my worksheets. So as you can see, this is difficult stuff. So these worksheets range from level 7 to 9. I don't think, until they get to the word question side, they're really not too bad. I think everybody here can do them. So this first question here perfectly summarizes everything about completing the square and solving quadratics with it. So let's do 1A first. So this is the completed square form. Now, the reason that it's called completing the square is because we want to express this as the square of something plus some constant. So the only x that you have is here. So whereas here we've got an x squared under 10x, here we've constrained the x just to this bit. So we've got a square, and then you complete it with this q, whether that be plus or minusing something. So the way that we do this is quite simple. The first thing that we think about is how do we get the x squared plus 10x? And then we worry about what to make the constant, because we can make this q anything we want to. So the way that we're going to get an x squared plus 10x by squaring something is if we do x plus 5. And the reason is because this is why I asked you to multiply out some brackets, was because when we square this, we get x squared plus 5x plus 5x plus 25. But the important thing there that I said was the plus 5x plus 5x. So you see, if we choose this number here as half of this one, we get our x squared plus 10x. So what we do is we start with this and work out what that gives us. So like I just said, we just expand this x squared, so plus 5x plus 5x plus 10x plus 25. Now we're actually pretty much there, because if you look at this, we've got our x squared plus 10x. So all we have to do is turn this 25 into a minus 3. So in order to make this side be x squared plus 10x minus 3, we look at what we've done to get from here to here. Well, we've subtracted 28. So that's all we do on this side. We say it's x plus 5 squared minus 28. And that is your completed the square form. Does that make some sense? Cool. Let me know if it doesn't. I will be doing some more examples, but I can explain really slowly again if you need me to. Okay. Yeah, sure. Someone's asked for, okay, a couple of people asked to go a bit slower with another example. Of course I can. What I'll do is I'll show you how to solve this one, then do another example, and I'll maybe write out my steps even more, the expanding and stuff to show you that. So that was part A. For part B, it says hence or otherwise solve this. So here's a hint. If it ever says hence or otherwise, using the hence, so using what you've just done, is going to make your life a lot easier. You will be able to do it in other ways. For example, here we could use the quadratic formula, but pay attention to when they say hence, because they're trying to give you a hint. They're trying to say use this. So if we rewrite this as we've just worked out here, x plus 5 squared minus 28 equals 0. So all I've done there is replace our quadratic with our completed the square form. It's the same thing, we've just proved that it's equivalent. And then what we can do is a really simple rearrangement, and it's the same every single time. We get rid of this constant, we square root, we get rid of this constant. I'll show you what I mean. First of all, we add 28 to both sides. So whatever that number is on the end, we're going to plus or minus that. Then we're going to square root both sides. So the square root of x plus 5 squared is just x plus 5 by definition. And this is root 28. Then, as I said, we want to get rid of this constant. So we subtract 5 from both sides. Now, one thing that I should have mentioned there is that this is plus or minus root 28. That's really, really key, because we know that quadratics can give us a maximum of 2 solutions. And to get that, we need that plus or minus in there somewhere. Otherwise, we just get one solution. And that comes from the rooting something. Because, for example, root 16 could be 4. It could also be minus 4. So we always write the plus or minus there. And then finally, we subtract 5 from both sides. Now, the convention is to write this at the start. So we write minus 5 plus or minus root 28. And that's your solution. You can pop this into your calculator and do it to a certain number of decimal places. We're going to be leaving them in surd form today, because it's easier. Okay. Let's go over another example, but do it a little bit slower. Sorry, I'm just making sure that I can reply to some people on the chat. So I'll do another one of exactly that same style, complete the square on this and then solve it. But I'll try to go a bit slower. Okay. Here we go. Here's a perfect one. Oh, no, actually, that uses a negative. We're not going to use that. Too difficult on here. Might have to come up with my own. Okay, let's just come up with one, and let's set it equal to 0 ourselves. So they have different ways of wording these things. They either say complete the square on this, or one of their favorites to say is like we saw in the last one and in this one, write it in the form here where a and b are integers. I think that can be quite mean of them because it can throw some people off. But just remember, if you ever see this standard form, this is like our base for our standard form for a completed the square form. Don't be thrown off. All it means is complete the square on this. Yeah, you don't want to be thrown off by the wording of a question when you can actually answer it yourself. Can anybody think what's the first thing that we need to do here? Someone asked if this is in all exam boards. Yeah. Someone asked, that's a good question actually, about the previous answer, whether or not you need to simplify the surd. Unless normally with those, you just put it into your calculator and then get the decimal, so you don't need to. So I won't be doing it today because I'd rather cover this stuff, whereas surds I covered in another lesson. Yeah, perfect. A couple of people have got it already. So what we do here is we want to find this bit first. We want to find what a is, and we want to find an a that makes sure that we get x squared minus 6x. We ignore the constant on the end for now, because we can make this be whatever we need to get this constant. So let's first of all think about what we need a to be, so that when we square this, we end up with the first part being x squared minus 6x. Now, it's got to be half of this coefficient of x, and I'll explain why really nice and slowly. So let's make a half of that. So in this case, half of minus 6 is minus 3. So we make a minus 3, so x minus 3 squared. Let's write that out. This is what x minus 3 squared means. And if we expand out these brackets, we get x squared minus 3x minus 3x plus 9. Now, we don't really care that this plus 9 was going to happen. We can sort that later. But what's really important is these parts here. Notice how we subtract 3x and then we subtract 3x again. That's always this number twice. So that means that the result here, when we combine this, is x squared minus 6x plus 9. And that's almost there to what we want. Then all we have to do is fiddle around with the 9, add something or subtract something to make it into a 1 instead. So we kind of think about this part first, and then the constant onto the end. So this is equal to x squared minus 6x plus 9. Now what we do is we see, well, we want to make this, we don't actually want it to be plus 9, we want it to be plus 1. So what do we do to get from a plus 9 to a plus 1? Yeah, brilliant. Loads of people getting that, which is fantastic. Yeah, awesome. So we subtract 8. So that's how easy it is to find b. We just think, well, how do we get from this to what we want? We subtract 8 from it. So if we're subtracting 8 from this, that's represented, we just whack the subtract 8 on here. Because then we know that if we do this, and I'll show you expanding it actually. So we take our x minus 3 squared and we subtract 8. Because then when we expand this out, well, we've just shown that this is x squared minus 6x plus 9. Then we've got that minus 8 on the end. So look, it becomes x squared minus 6x plus 1, which is exactly what we wanted it to be equal to. So here is our completed the square form. Does that make a bit more sense to those who wanted me to go slower? Just let me know in the chat. And whilst you're doing that, I'll set this up to solve it. So the question could then be hence or otherwise. They always say or otherwise because you can use different methods. They don't want to restrict you. So solve like this equals 0. So it will be, solve x squared minus 6x plus 1 equals 0. So what we do is we replace this with what we've just said our completed the square form is. So now all we want to do is rearrange this to get x on one side and our two solutions on the right hand side. So what do you think? Brilliant. Louise has got the solution already. That's fantastic. Okay. A couple of people are saying, a couple of people are saying that they're still a bit lost. I'll do one more really slow example after this. I think the more you see, you'll really get used to it. I definitely found this confusing when I first did it. So don't be disheartened at all. You'll see me doing more and more, and you'll see that it's the same thing every single time. So who knows what we have to do first to solve this equation for x? Excellent. So the very first thing that we do is we add 8 to each side. So adding 8 to each side leaves us with this. What's next to solve this? Someone said you have to do loads of working out to get full marks. You should probably show your working a little bit. In the next one, I'll show you exactly how I would lay it out if it was an exam question. Brilliant. You square root both sides. So this becomes x minus 3 equals root 8 plus or minus root 8. Now that's the key part. Because like I said before, root 16 could be 4 or it could be minus 4 because minus 4 squared is also 16. So we put the plus or minus root 8. Just like in the quadratic formula, you've got a plus or minus in there. That's what that's for as well. You've got to make sure that you're accounting for both the possible solutions of this quadratic. And then we just add 3 to both sides. So x is 3 plus or minus root 8. And then you can just pop this into your calculator, 3 plus root 8, 3 minus root 8, and there are your two solutions. Okay. Okay. I'm enjoying the Q&As pretending to be from Maths Made Easy. Okay, we'll go over another really similar one. Let's do this one. Right. So again, exactly the same style of question. Write this in this form. So, who can tell me what we have to do first to get this into completed the square form? And I'm looking particularly for those who said they were struggling. Just give it a guess. I'm obviously not going to name names, but if you were struggling, just give it a guess, because then I can see where your thinking's at and how I can. Anyone else got any ideas? Brilliant. People are already managing to work out the answer. Fantastic. Cool. Some people already got the answer. Brilliant. Some people having some good ideas. Okay, cool. So, okay, let me go through some of the answers that I got. So one of them saying, a couple different people saying x minus 4, which is perfect. Some people have different numbers on the end, and we'll work out what that is in a moment. But yeah, so, and someone suggested half 5. Really, really, really close. It's the 8 that we want to half. And the reason is because we want to express it in this form here. We basically want to work out what these a and b need to be. So what we do, as I've said in the previous two, we ignore the constant on the end. Forget that. That's going to come in a moment. So we think, what do we want a to be, so that when I square this, the first two parts read x squared plus 8x. Well, it's definitely going to read x squared. That's just how this is going to work, right? This is how it's going to be expanded. If I put a 4 here, I'm going to get x squared plus 4x plus 4x plus a constant, which we'll think about in a moment. So that's exactly what we want. Someone said, so 8 is representing a. Not quite. The a is the 4. But a is the number that we choose to then get to get that 8. So a is actually half of 8 in this case. A just represents that number that we're going to have in the final equation of it. Okay, someone's asked me to re-explain. I'm more than happy to do that. I'm trying to think of it. If you could let me know, like, specifically which bits you'd like me to go over, because yeah, I don't want to just be repeating myself, because, you know, if you don't understand it in one way, there's no point in me repeating. I'll try explaining it in a similar way, but just let me know if I can help in a different way. So basically, we're trying to express this in this form. We're just trying to rewrite it. It's like how if you had, you know, when you solve a straight line equation and it says express it in the form y equals mx plus c. It's just the form to put it in. That's all this means when it says express it like this. So we want to rewrite this so that it's something squared plus a constant, because this is a really useful form for us to have it in. So what we think about first, we just take it step by step. We can't obviously immediately see both numbers. We have to take it step by step. So we're going to first think about what the a should be. Now, this a needs to be something that when we square this x plus a, it gives us x squared plus 8x plus something. Because the plus or minus, whatever it is on the end, can be fixed with the b. We can change that. But we want to choose something for this a, and as Olivia's just rightly said, yeah, it will be 4. And the reason is because when we expand this out, we get 2 of whatever this is. Because when we expand this, we get x squared plus ax plus ax. And it's that 2 lots of the adding the ax that gives us double it, which is why we need it to be half of this. So we start off by saying, well, we know that a has to be 4, because if it's anything else, we won't get this 8x. So that's what we start off by doing, is saying that we know a has to be 4. So we know that this has to be the first part. And then it's plus b. Whatever that b is going to be, we're going to figure that out now. And the plus b is the part that's going to make this plus 5 on the end. Oops. Remember, we need both parts of this. So how are we going to figure out what that plus b is? How are we going to figure out what it needs to be? Well, let's work out what this is first to see kind of the leftover from this. Because all we wanted this to be was just to give us our x squared plus 8x. But obviously, it's going to have a constant on the end. So we just want to knock off whatever we need to from that constant to make it fit what we need. Yeah, exactly. Fatima said exactly right. Expand the bracket and see what's needed. Yeah. So we can, oops. Oh, did I just stop sharing? That was smart, wasn't it? Try to click on the Q&A. Okay. So why don't we, let's try expanding this to see what we need to pop on the end. So who can tell me what we get when we expand x plus 4 squared? Brilliant. Cassia's got it. Fatima has it as well. Brilliant. Just give it a tiny bit longer in case anybody else wants to have a go. Cool. So a couple of people are already getting the full completed square form as well, which is fantastic. So yeah, brilliant. Okay. So one thing that I want to point out is that when we have this, this is not x squared plus 16. That's a totally valid mistake to make. I can totally see where that comes from. I used to make that all the time and honestly still do. What you've got to remember is that this is the same as writing x plus 4 times x plus 4. So we've got to multiply every bit with every other bit because that's where our 8x comes from. So like pretty much everybody got, when we square this, we get x squared plus 8x plus 16. Now here's how you've got to think about this. The x squared plus the 8x is great. That's what we wanted to get from this expansion. The 16 is kind of the unfortunate fallout from the end that we didn't really anticipate. We don't, well, I mean, we did, but we don't really care about that. We want this to be a 5 instead. So what can we subtract from this to make it 5? What can we do there? Cool, a few people getting it, which is fantastic. Brilliant, loads and loads of people getting that, which is brilliant. We can subtract 11. So subtracting 11 on this side gets us this. So if we subtract 11 on this side, that's basically all we're doing. If we write it like this, x squared plus 8x plus 16. Sorry, plus 5. You see, all we've done here is we've subtracted 11 from this side and we subtracted 11 from this side. Well, now this is what we wanted it to be. It's x squared plus 8x plus 5. So this is equal to that. So this must be the completed the square form. So we see that our a is 4 and our b is minus 11. So hopefully that makes some sense. Don't worry if you still don't get it. This is a difficult topic, as I've shown from the questions. So really don't worry about it. It's practice. Hopefully just from these first 3, you've seen that it's the same process every single time. We just choose our A, expand that out to see what our B needs to be. So it's not too bad. You see, I've only done it in 2 lines here. And in fact, this is all you would need to write down on an exam to get full marks on this question. So hopefully you can see that it's not as scary as it kind of first seems. Hopefully it's not as overwhelming as you maybe thought it was. So we're going to have a go at another. And then I'm going to show you about this whole coordinates, coordinates of the turning point thing, which is what this question and this format is often used for. So we've got one here, another classic, exactly the same as before. So give it a go. Either just pop on the chat your final answer, or if you're not sure, maybe just say where you think you would start with it. Just give it a go. Just take a guess, even if you're not sure, because then it helps me to see where it is that you're misunderstanding and where I can help you improve with it. Brilliant. A couple of people already getting it, which is fantastic. Loads of people. This is really, really promising. Cool. So everybody has either done the completed the square form, solved it for when it's equal to 0, or kind of told me where they would start with it, which is fantastic. Brilliant. Okay, loads of people are getting this, which is super, super encouraging. So let's go ahead and do this one together. So we're going to start off by thinking, okay, let's get our A first of all. This B can be sorted at the end. Let's work out what we need A to be to get 10x. And loads of people were saying it, you've got to half it. So it's going to be a 5x. So we do x plus 5 squared. That's definitely going to be the first part of this. Now we need some sort of process to find out what B is going to be. So let's expand this and see the kind of the junk that we're left over with that we want to reduce to 2 to get it into this form that we want. And as loads of people said, when you expand this, you're going to get x squared plus 10x plus 25. Now, look how close this is to what we want it to be. But unfortunately, we've got a 25 on the end here instead of a 2. And how do we get from 25 to 2? Well, we subtract 23. So let's do that. Subtract 23 from both sides. So here we subtract 23. And here when we subtract 23, it gives us that 2 that we wanted. Now look at this. That x squared plus 10x plus 2 is exactly what we wanted. And this is equivalent to it and in the right form. So this must be our answer. Okay, brilliant. So someone said they can get to the x squared plus 10x plus 25 part. That's brilliant. That's genuinely, that's the hardest part done. Because all you've got to do now is think about the B. Because all you've got to do is see, well, this is really, really close to what I want. So this is really close, but it's just 23 too much. So just take that 23 off. And then you have it there. So lots of people are asking for one more. I can absolutely do one more. I'm going to show you about the turning points of this, and then we'll do one more and integrate the turning points. Someone said, can we try some minus questions? Yeah, I do have some ones with negatives and bigger coefficients of x lined up. I'm not sure if I'll get round to it today, to be honest, because I'd rather, these are much more common, so I'd rather everybody understands these concepts. But I'll definitely give it a go if we can get round to it. That's what we'll do. So let's take this example. Now, the next question, in fact, on here says, Hence or otherwise, our favourite saying, write down the coordinates of the turning point of that graph. Quite an overwhelming question, but the good thing is it says write down. Now, when you see write down anything, you should jump for joy because it means that you don't have to do any calculations. Write down means it's something that you can see. There'll be a 1 or 2 mark question. It's something that you can see, and it means that if you can do it once, you can do it for every type of question. So whenever you see write down in a question, don't be overwhelmed by it. Don't worry about it. You know, you'll be okay with it. Okay, so let's think about what on earth this means. So let's sketch this graph first of all of x squared plus 10x plus 2. Well, we know it's going to be a quadratic and a positive quadratic. I'm actually not going to put any axes on yet because we don't know whether it crosses the x-axis, whether it's mostly on the right, mostly on the left. We could work that out, but we'll work that out actually from the turning point. So all we know right now is that it looks like this. Positive x squared, so it's a smiley face curve. So what we want to do is find the turning point. And the turning point is this here. It's the point where the gradient starts to change from negative to positive. It's literally the point where the graph starts to turn. That's why it's called that. It's also called in some exam boards or in some questions, the vertex. So normally I think you'll know vertex to be like a corner of a cube or something. That's a vertex. But it can also mean this, a turning point. So just somewhere where it starts to change directions. So does anybody have any ideas about how we can find this turning point here? It's quite tricky possibly if you haven't seen it before. Some people kind of have it or are really close to it. But can you tell me why it's that? And don't worry if you don't have any clue. Loads of people have no clue. That's good. That actually makes me very excited because it means that I can teach you something new. And I think that you guys should get this. I don't know, fairly quickly, or maybe with a rewatch of the video. Because if you followed this far and everyone seems to be on top of this, then fingers crossed. So what we have to notice about this is that this is the minimum point on the curve. So we want to know both the x value and the y value. That's how we get a coordinate. Now this curve is obviously the curve of y equals x squared plus 10x plus 2. So that's the same thing as saying that it's the curve of y equals x plus 5 squared minus 23. Right? Because we've just proven that this is the same as this. Now, this is a minimum point on the graph. So we want to know what the lowest this can possibly go is. Well, what is the smallest square number? Give it a guess. If you've said 1, have another think. A couple of you've got it. So the smallest square number. So some examples of square numbers, 1, 4, 9. So you know if it's not 1, it's got to be smaller than 1. Because, yeah, loads of people are getting it now. Excellent stuff. It's going to be 0. So the reason is because square numbers are whole numbers, but basically when you square something, you get to them. So 9 is a square number because it's 3 squared. We can't have negative squares because if you multiply something by itself, it's positive because you're either multiplying 2 negatives together or 2 positives together. So what that means is that every single square number is positive, or at least non-negative. The difference between non-negative and positive is that non-negative includes 0. 0 is a square. It's 0 squared. So 0 is the smallest square number. So if we're trying to make this y expression the smallest it can be, we want this square to be the smallest it can be. So when this square is equal to 0, that's when it's smallest. So when this whole bit is equal to 0, so we can visualize that, this whole bit is equal to 0. First question, what does y equal? When that bit's 0. Yeah, a couple of people getting it. In fact, a few now. Brilliant. Tons of people getting that. It will be minus 23. Hopefully you can see that from here. When this whole square bit is 0, y equals 0 minus 23 or minus 23. So what that means is that the y coordinate is minus 23. There's no way it can go lower because there's no way that this square bit can go any lower than 0. So it has to be minus 23. That's as small as we can possibly make it. Now, what value of x causes this to be 0, do you think? Brilliant. Cassia has it. Smart dude has it. Well, actually, smart dude, not quite. Not quite. I misread it. Yeah, there you go. So I'll reword that slightly, give you a little hint. So what value, so basically we want this whole squared thing to be 0. So we need it to be 0 squared. So what value of x makes x plus 5 be 0? What can we add to 5 to make 0? Brilliant. A couple of other people getting it now. Okay, cool. So I'll go through it. So it's going to be minus 5. If x is minus 5, then minus 5 plus 5 is 0. So we say that x is minus 5. So do you see what we've done here? We've said the smallest that this can possibly go, because this is the minimum point, the smallest it can be is minus 23. So this must be minus 23 down. And what value of x is it that causes that to happen? Well, it's the value of x that causes this to be that 0. So it's got to be minus 5. And now we've got our x value and our y value of this point. So the turning point is minus 5 minus 23. If you need a quick way of remembering it, it's this, the negative of this and this here. But I never liked remembering that because I'd be like, oh gosh, which one is it the negative of? I always think it's so much better if you can actually derive it yourself and see why it is that it exists. So we've only got 10 minutes, so we're going to do one more really quick one like this and then do the final Kahoot. So let's look at one more, shall we? Let's do this one. Ooh, wrong tabs. So I'll just give you guys about a minute or so. See if you can tell me the completed the square form and therefore what the turning point is. If you're not sure how to actually get there, just tell me how you would start. Tell me as many steps as you can do. Someone's asked a really good question. If the 5 was already a negative, would it become positive? Yeah, exactly. Because you want that thing in the brackets to be 0. So if it's a minus x minus 5, x has got to be 5 to make that thing 0. Cool. A couple of people already getting it, which is fantastic. I'm going to go through it now. Sorry if you've only got a little bit of the way. Just want to make sure that I can do the manage the Kahoot as well. So I'll go through this one fairly quickly, like I said, so that we can do the quiz. So let's put it in completed the square form. First thing that we want to do is work out what we need a to b to make x squared minus 2x. So we're going to need it to be minus 1, half of that minus 2. And the reason is because then when we square it, we get x squared minus x plus 1. And that minus x gives us our minus 2x. Minus 2x plus 1. Now, this is really, really close, but instead of a plus 1, we want a minus 1. How do we get from plus 1 to minus 1? Well, we subtract 2. So here is the completed the square form. This bit here. So then the turning point, well, let's think about it. If we have y equals that, the smallest that y can go is when x minus 1 is 0. So the smallest that y can go is minus 2, and that occurs when x is 1. So that's how you answer that question there. Sorry, that one was a bit rushed. Feel free to ask me questions about that whilst you're joining the Kahoot, because we've got 7 minutes. That's all right, we'll be okay. We'll just have to do some of them a little bit quicker, but at least we got through all of the content. Okay. So I'm just going to give it a minute or a minute and a half for people to join. Feel free to ask any questions you have whilst people are joining. It's a good time to do it. Someone said, can you do completing the square with a coefficient of x squared greater than 1? I don't know that was saying, is it possible, or can I do an example? You can, it is possible. So what you have to do for those, whilst people are joining, hopefully you have that pin, I'll just pop it in the chat. What you have to do is, so say, yeah, it's a really, really good question. And maybe we'll cover it in a future lesson or something, I'm not sure. But say you had 2x squared minus 4x. No, let's do minus 10x plus 6 or something. What you have to do is take out that power of 2. Complete the square on this bit, like we know how, and then multiply everything back by 2 again at the end. So feel free to give that one a go. Sorry, I didn't get a chance to get there today. I wanted to make sure that everyone had the basics. Root 0, that's a good one. Oh gosh, I didn't check who won out of 10p Asperg or 9p Tesco Ag. Can one of you get on the podium? That'd be exciting. Square root minus 1 equals yeah, it does. Complex numbers. Very, very exciting. Thank you. Right, okay, it's 5:02, so we're going to get going. Feel free to join once we've already started. I can't believe some people turn off names on Kahoot. They're so creative. Gotta love them. Okay, so this is to get us into it, expanding a squared quadratic. We know now that this is how, hit my screen. We know now that this is what we need to do as part of completing the square. So give it a go. Brilliant, loads of people getting that. So we get an x squared and minus 18, both of these, and then a plus 81, because it's minus 9 times minus 9, so it becomes a positive. Okay, just a straight completing the square question. So see if you can get this one. Fingers crossed. I'm going to leave this for the whole 60 seconds. I might skip a bit further ahead, skip a bit quicker on some of the last ones, but I'll shut up as well so that you can actually answer it. Almost there. Okay, yeah, awesome. Loads of people getting that. So I don't have time to fully write it all out, but it's really similar to previous examples. We would have to do x minus 3 square, x plus 3, square that, and we'd get x squared plus 6 plus 9. So we've got to take off that 11 to get back to what we wanted it to be here. Okay, now we've got another one. It's a instead of x this time. Terrifying, switching up the letters. Oh, this is also a horrible one because you're going to have a fraction, which I didn't get a chance to covering. See if you can do it by using a calculator. It's not that different. You've just got some fractions / decimals in there. Still half of this. So give it a go. I'm going to stop this timer this time when it gets to 15 seconds so that we have time for everything. Oh no, answers are still coming in actually, so I won't. I'll leave it all the way. Okay, awesome. So the good thing here is, even though a lot of people went for this one here, you could see that it was a plus 1.5. So that's a fantastic start. So yeah, what we have to do there is, when we expand this, it'll be a plus 3a, and then plus whatever 1.5 squared is, 2.25. And then see that we have to subtract 8.25 to get that back to minus 6. So yeah, it's a tricky one, especially because we didn't go over fractions. So well done, and well done to everyone else as well, because you did you got the main bit right, which is fantastic. So here we've got to complete the square and then find the vertex. We don't have much time for this one, so I'll be quiet. Oh, nice. Well done. Yeah. The reason was probably because there wasn't much time for that one. I'm sorry, I should have checked and changed the timing on that question. But yeah, well done. So you've got to complete the square, and you'll see that it will be x minus 3 squared plus 4. So then we make the 1 by the x, flip the sign, make that be 0, and then it's the y value is on the end. So, oh, there's more questions in this one. I forgot I added more to the final one. Sorry, we're going to run over by a couple of minutes, but not much. So, back to the beginning of the lesson when we were solving the equations. Who can remember how on earth we did that all those 40 minutes ago? I'll stop this one when we get down to 20 seconds, just so that we don't finish too late. Yeah, this picture's actually a bit terrifying, isn't it? That robot on there. Cool, skip that now. Okay, well done. The reason is because when you do this, it'll be x minus 3 squared minus 11. So when you rearrange, you get 11 on the other side, square root that, and add your 3. So that's why it's that one. So that one's clearly one that could maybe do with, maybe I could have spent longer on that. Hard to get everything in. So now we're just looking for the value of a here. These videos are on YouTube. I may as well start telling you this stuff now. These videos are on YouTube. MyTutor has a YouTube channel. So I really encourage you, if you're still not sure on some bits, rewatch it. It can help so much watching it a second time. You know, slow me down to half speed. Do whatever works for you. Drawing along with the quizzes again, just writing them down. Fantastic. Well done. For those who said 7, super close. Just the sign. sign difference there. And final question. This is a super quick one. Just look at that and tell me what the turning points are. So you haven't had to complete the square on it. Can you remember? Let's see, can people remember? Yes, they can. Woo, well done. So we make this one a positive version to make this bracket 0, and then this one becomes a 4. Fantastic. So let's have a look at the podium for that. Third place got 5 out of 7. Brilliant. Oh, 10p Asda bag. Oh my gosh, there's 9p Tesco bag. They're going to overtake. Smart dude in second. Oh, and with full marks. Cassia, well done. Amazing. Superstars. Let's view the report. Let's see if the percentage went up. There were some hard questions there, so no, it didn't. That's all right. I feel like you guys did better at the end. Oh well. There were more questions and they were a bit harder. Thank you all very much for coming. As I said, check out the MyTutor YouTube channel for this video recorded along with all of the others. And there's also the schedule. Oh my gosh, maths joke. Emma sent me a maths joke. She's keeping these maths jokes alive actually, so thank you. What do you get when you cross an algebra class with the prom? The quadratic formal. I will feel free. Other people can send me in jokes. I love them. I love when you guys send me. I have so many to yeah, so many to do. So anyway, thank you. I'm sorry that I overran. Check out the timetable for what's coming up next, and I will see you next week. Bye guys.